So this really should have been with 8.4. This is, again, we're dealing with a cone. We dealt with surface area and volume of a pyramid in one section. For some reason or another, they've separated 8.5 into its own section, but we're just looking at volume of a cone. Okay? Cone, of course, cone-shaped containers are used in a variety of professions, such as environmental studies, agriculture, and culinary arts. In this section, you will develop a formula for the volume of any cone. So we're just going to skip again, straight to the example. We don't have some of the materials that they're asking for in the investigate, so let's just go quickly to the examples. The formula for volume of a cone. It's just 1/3 the volume of a cylinder. That's all it is. So we know our volume of a cylinder is pi r squared times h. For a cone, we're just going to cut that into 1/3 because of that point that goes to the middle. All right? So that's the only difference. Volume of a cylinder, very easy. You take the surface area of a circle, which we know is pi r squared. That's our base. We multiply it by the height. That now becomes our volume. Does that make sense? It's like you're taking that area and you're slicing it all the way up. Right? That's what we do when we multiply it. Same thing with a cone. The only difference is that now we take that area, and because it's coming to a point in the middle, it's being multiplied by 1/3. Okay? So if you have a cone and a cylinder, the same height, the volume of the cone will be 1/3 of that of a cylinder. And that's because you're losing all that volume around where the cone is pinching up to a point. Make sense? So very simple equation. It's 1/3 the volume of a cylinder. So the example is Tracy makes her own frozen yogurt treats in cone-shaped paper cups. Determine the volume of the frozen yogurt treat shown to the nearest cubic centimeter. So here we're given the height and we're given the radius. So all we do is plug that into our formula, which is 1/3 volume of a cylinder, which is area of the base, times the height. So pi r squared times height. So plugging in the radius, which is 4, and the height, which is 12. We take 1/3 of that, 201. Any questions about that? Volume of a cone. Very simple. Everyone agree? Easy? I hope. All right, example 2. Volume of a sand pile. Same idea. We have a cone here. We have, this time they give us the slant height, and looks like they give us the diameter. Yeah, diameter of 10. So what might you guys think we'd want to do right away? Here. You go.
Find the height.
Yeah, we want to find this height. Okay? And what are we going to use to find that height? Michael.
Pythagorean theorem.
Right, Pythagorean theorem, and our two sides are going to be what?
10 and 8.
No. Not 10. Sorry? You're close. Not 10 though, because remember, 10's the whole diameter, right?
Oh, just 5.
Right, so it would be 5 and 8. So there's our triangle here. 5 and 8, and we're going to solve for height. Why do we need the height? Because it's in our volume formula, right? It's pi r squared times height. So we need the height. So we solve for the height, which is 6.2. Again, using our Pythagorean theorem. This time paying careful attention that the h is one of the smaller sides, not the hypotenuse. So don't make that mistake just because it's the unknown, putting it on its isolated side. You need to subtract from the hypotenuse to find h. Okay, so we have our height there, 6.2. Once we have our height, we can plug directly into the formula 1/3 pi r squared h, where r, of course, is 5, and the h, which we just solved for, is 6.2. We find our volume to be 162. Of course, not forgetting the units, which we would go back to the original problem to find. Any questions with example 2? One more example. It's a fountain firework is packaged in a conical container. Its volume, so they're giving us the volume this time, is 210. Its diameter is 8. So we have the volume and we have the diameter. If we have the diameter, we also have the radius, right? So we have the volume and we have the radius. I imagine it's going to ask us for the height. And what is the height? Yeah, yes, it is. What is the height? Nearest to 1/10 of a centimeter. So here we need to use a bit of algebra skills. So you need to freshen up here. We need to isolate for the height. So remember how we do that. We have a fraction here of 3. So we're going to times the 210 by 3, right? This will eliminate the 3 on the right-hand side, and this will become 630. Okay, so we'll end up with something like this. 630 is equal to pi 4 squared h. Next step is you want to divide both sides by 4 squared. So these go, right, divided by 4 squared. Okay, or 16. So you would end up with, what's 630 divided by 16? Yeah. 39.3. So that's equal to pi h. Now, don't confuse pi as being a variable. It's not. It's just any other number, right? It's just, well, it's just one specific number. It's 3.14. So on your calculator now, what would be the next step here? What do we do, Matthew?
Divide 39.3 by 3.14.
Excellent. Or you would use pi on your calculator. Okay? And that goes back to the algebra skills that we've learned previously. Christian.
When you're bringing up down that formula with algebra,
Yeah?
is the first thing you have to do get rid of that fraction? Because when I thought of doing it, I figured because you have 1/3 the pi and then the radius, could you just solve for that and you're left with whatever you get there in the height, and then divide 210 by that?
Yes.
That was over.
Yeah. You could have just done 1/3 times pi times 4 squared, got a number times h, and then divided 210 by that number, yes. Okay? You can do either way. So the key concepts, the volume of a cone is 1/3 the volume of a cylinder with the same base, radius, and height. So there's our formula for volume of a cone. Very easy formulas, right? We need to know these for EQAO, right? We need to remember these formulas. They're simple. If you know the slant height and base radius r of a cone, you can use the Pythagorean theorem to determine the height. So if we know this side and this side, we can find the height. Any questions with 8.5?